This is question 54 on chemistry from the 2018 NSAA. So you're told that the following reaction releases this much heat for each mole of oxygen that reacts. So nitrogen monoxide plus oxygen forms nitrogen dioxide in a reversible reaction. You're told that an excess of nitrogen monoxide and Y moles of O2 are mixed and that they reach equilibrium in 1 hour. And at equilibrium there are Z moles of NO2. So the question is, assuming constant pressure, how much heat is released over the hour? So where should we begin here? I find that with the equilibrium questions where it talks about moles, it always helps to do this sort of diagram where you have the equation, the initial moles and equilibrium moles. So let's fill it in. We're told that we have an excess of nitrogen monoxide and Y moles of O2 initially, and if that's the initial conditions then we'll have no NO2 at all. And equilibrium, well, if we start with excess NO, then we're going to have excess NO at equilibrium as well, because that's just how excesses work. How much oxygen will we have? Well, that depends on the nitrogen dioxide that we formed. So we're told that there are Z moles of NO2 at equilibrium. So how many moles of oxygen does that leave? Well, we started with Y. We produced Z NO2s. So what does that leave oxygen? So the coefficient 2 means that we produce twice as much NO2 as the oxygen that we use. So that means it's not Y minus Z, but it's Y minus half Z. So we've worked out how many moles of each substance we have at equilibrium. So what now? Well, we're asked how much heat is released over the hour, and we're told how the oxygen consumption affects how much heat is released. So we need to know how much oxygen is reacted. Can we work it out from this? So if we started with Y moles of oxygen, then we ended with Y minus Z over 2 at equilibrium. How many moles of oxygen have reacted? That's Z over 2 moles. So how much heat does that correspond to? Well, we know that 1 mole of oxygen forms 116 kilojoules of heat. So how much heat does Z over 2 moles produce? So if we multiply 116 kilojoules per mole by how many moles we have, Z over 2, that comes out as 116 over 2Z kilojoules. What's 116 over 2? That's 58Z kilojoules of heat. And this corresponds to answer E on the question paper.